So we mentioned the discovery and special features of protons, neutrons and electrons. But in short, we want to explain the discovery of neutrons. So this is example, that is beryllium atom or beryllium nucleus is in the form of target. Alpha particle, that is helium nucleus, is in the form of projectile. Main product obtained during the interaction of target and projectile is nothing but, that is carbon, and one particle is ejected or emitted, that is called as neutron. So these are the four, that is target and projectiles are in the form of reactants at the same time. Main product and emission is in the form of product. So whenever this target, that is the nucleus of beryllium, is hammered, whenever the nucleus of beryllium in the form of target is hammered with the help of fast moving projectile like alpha particle, then a product, main product is obtained, that is called carbon 612. 6C12, that is main product in the form of carbon, and one particle is ejected or ejected particle, or the particle which is given out during the artificial transmutation or artificial radioactivity is called emission. So this is the example of artificial transmutation, that is one element, that is beryllium, is converted into non-radioactive element, that is carbon, with the help of fast moving projectile. Hence such type of reaction is called artificial transmutation, and during this preparation of synthetic elements, neutron is discovered by the scientist James Chadwick. So target is the substance, or it is nothing but the atom of an element which is bombarded by a fast moving projectile. Projectile is a fast moving particle or a high velocity particle which bombards the target, is called a projectile. Or the product which is obtained by interaction between projectile and target during artificial transmutation or artificial radioactivity is called main product. And during artificial transmutation or artificial radioactivity process, the particles which are ejected or given out is called emission. So in this way, during artificial radioactivity and artificial transmutation, discovery of neutron takes place. So this is all about discovery of neutron, discovery of proton and discovery of electron, and the characteristics of all these subatomic particles of the nucleus, proton, neutron and electron. So this is all about the characteristics of protons, neutrons and electrons, special features of all these subatomic particles, and discovery of proton, neutron and electron. Now we want to discuss the second part of this atomic structure or structure of an atom, that is Dalton's atomic theory, then Rutherford's atomic model, then Bohr's atomic theory. So these are the three theories: Dalton's atomic theory, Rutherford's atomic model and Bohr's atomic theory. Gives the perfect position or perfect identification or idea about atom and external as well as internal structure of an atom. So first of all, atom is a term used in inorganic chemistry, that is in the study of elements. In the periodic table, in Mendeleev's periodic table or Moseley's periodic table, there are 118 elements today. Mendeleev's periodic table contains 118 elements. So the smallest particle of an element is called an atom. Smallest particle of an element is called an atom. So atom is the smallest particle of an element. This is the basic, simple definition of an atom. That is the smallest particle of an element. In simple words, the smallest particle of an element is called an atom. So this is the definition of atom. The characters of atoms are, the first one, that is indivisibility, indivisible in nature. In simple words, that cannot be further subdivided, cannot be further subdivided. So atom is the smallest particle of an element. It cannot be further subdivided by any chemical method. The first point regarding atom, it is the smallest particle of an element. Smallest particle of an element is called an atom. Second point, atom is indivisible. Atom is indivisible in nature. It cannot be further subdivided by any chemical method. So these are the characters of atom. Activity. So this atom is defined, or it can be characterized on the basis of these points. That is the smallest particle of an element. This is number one. It cannot be further subdivided by any chemical method. That is, it is indivisible in nature. It is active in nature as compared to molecule. As compared to molecule. Atom is active in nature as compared to molecule. It is very simple. That is, atom contains number of electrons. Molecule never contains electrons, unpaired electrons. So activity of an atom totally depends upon availability or presence of unpaired electron in the atom. So atoms give active character, explains active character due to presence of unpaired electrons. So these are fresh points regarding this atom. Now we have to discuss the next topic, the next article, that is isotopes. Isotopes and isobars. Isotopes and isobars. Isotopes and isobars. Characteristics of isotopes. Characteristics of isotopes. Characteristics of isotopes. So, the third important article in this particular topic is nothing but introduction, characteristics of isotopes, characteristics of isobars, and finally the distinguish or the difference between isotopes and isobars. Initially today we discussed only the characteristics of isotopes here. So examples are written on the board, that is H11, H12 and H13 is the first example. Second example written on the board, that is O816, O817 and O818. So these examples, by taking only examples into consideration or putting examples in front of you, it is very easy to give the distinguish or the characters of isotopes, isobars, and the characters of both isotopes and isobars. So first of all, we are going to define the term that is called as isotopes. These two examples of isotopes explain that oxygen, we know that oxygen is only element which is present at the 8th position in the periodic table. It means oxygen has an atomic number equal to 8, hence it is placed at position 8 in the periodic table. At the same time, this hydrogen, we know this, which hydrogen has an atomic number equal to 1. Atomic number is equal to 1, hence first member of the periodic table is none other than hydrogen. So these examples set in front of you are that is atomic number of hydrogen is equal to 1. It means it has hydrogen, oxygen, oxygen, oxygen. It means that isotopes are the examples of same element. Isotopes are the examples of same element. As they are the examples of same elements, itself indicates that isotopes have same atomic number, and at the same time isotopes have different atomic mass number. So in the definition given, in the definition of isotopes, isotopes are the different atoms of the same element, that is oxygen, 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 hydrogen, hydrogen, and hydrogen. Different atoms of the same element having same atomic number, but different atomic mass number called isotopes. So in simple words, different atoms of the different elements having same atomic number and different atomic mass number are called isotopes. So as an example itself indicates that oxygen, 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 hydrogen, hydrogen, hydrogen. These are the examples of isotopes. It means that isotopes occupy fixed or same position in the periodic table. So position of isotope is fixed in the periodic table. Hence isotopes have same position in the periodic table. This is the second one. Oxygen, oxygen, oxygen. Whenever oxygen takes part in a chemical reaction or hydrogen takes part in a chemical reaction, it shows same chemical properties. Hence, the chemical properties shown by isotopes are identical or similar. Hence, the third point can be written that isotopes show same chemical properties. Valency. So, valency is the concept. Valency is the term which depends upon the tendency of an element to give. That is, tendency of an element to donate or accept the electrons. So oxygen, when we bifurcate this oxygen, that is K and L, 2 and 6. Oxygen contains 6 electrons in the valency shell, that is L. Valency shell or outermost orbit of oxygen is 6. It requires 2 electrons. That is, 1 electron is called -1, 2 electron is called -2. So valency of oxygen is -2. So -2, -2, -2. Hydrogen has only 1 electron. That is, hydrogen is capable to donate. Hydrogen maximum donate a single electron. Hence can be written that is +1. So valency of examples of isotopes is the same. They show same valency. Isotopes, they show same electronic configuration, and electronic configuration totally depends upon the atomic number of an element. So isotopes show same electronic configuration. And finally, isotopes contain same number of protons because they have same atomic number, and different number of neutrons because they have different atomic mass.